All right. Balancing chemical equations. Okay. If something is balanced, why is it balanced?
That's an equal amount on each side.
Equal weights on each side, equal amounts on each side. That's how you get things to balance. Equal force on each side. Okay. So that's what we're trying to do. And the sides are before and after reactants and products. Okay. So let's talk about balancing equations. Okay. The reason why we have to balance it is because atoms can't be created or destroyed. We don't have that kind of power. You're not going nuclear on me. Okay? So all we can do is rearrange them. So all we're going to do is rearrange atoms. Another way of saying this is that every atom I start with, I have to end up with. Law of conservation of mass. Dalton is the guy who is credited with a lot of it, but lots of people put into it. But give Dalton law of conservation of mass. Doesn't get a person's name. Hey, so we said balance means it has to have the same on each side, and what it has to have is the same of each kind of atom. Not every kind of atom, each kind of atom. Each means the hydrogen has to equal the hydrogen, and the oxygen has to equal the oxygen, but the hydrogen does not have to equal the oxygen. So they each have to equal each other, but they don't all have to equal each other. So every carbon atom I start with, I got to finish up with. Every hydrogen atom I start with, I have to end up with. So I got to keep track of how many atoms. And the computer did that for us when you did it. It kept track of it. It said, hey, it's balanced. It's not balanced. Okay, so let's talk about how to balance an equation. Carbon and oxygen comes as O2, makes carbon monoxide. Carbon plus oxygen makes carbon monoxide. Pictures, equation, same information. Is this balanced? Well, there's a carbon and a carbon, but there's two oxygens here and only one there. We need more oxygen in the products. Hey. Well, that's easy to do, Mr. Green. All you have to do is take and put a 2 right there. There's only one little problem with that. You're not describing the same thing you started off with. Carbon and oxygen make carbon monoxide, a poisonous gas. Carbon and oxygen make carbon dioxide, a not so poisonous gas. Talk about something completely different. I can't change the formula because the equation describes what really happens. I have to make carbon monoxide. I can't just put a 2 here. I just can't draw another oxygen over here and say, ooh, we're done. That doesn't work. Can't do that. Those have to go away. Because the equation is a sentence that describes what really happens.
So you're saying that the equation enters unbalanced?
It's unbalanced because it's got
It's like
one more oxygen on the right-hand side. I need a total of 2 oxygens on the right if it's going to be balanced. Okay. So I need more oxygen in the products. But the only product I can make is carbon monoxide. So the only way I could use two O's and make carbon monoxide is to make two carbon monoxides. That's the only way I can use both O's and still make carbon monoxide. I don't have a way around it. I can't change the formula. I can't add a subscript. I can only add a coefficient. I want two COs. But that leads to a question. Is it balanced yet? Where'd that other carbon come from? Well, do you think there will ever be a time in your life when you are working with an individual atom of carbon? No, it's not going to happen. Carbon atoms are way too small and there's way too many of them. You're always going to have bunches of them. So the answer is we just don't, we don't use carbons one at a time, we use carbons two at a time. I had to have started with two carbons. Now, if you look at my pictures, they still say carbon and oxygen make carbon monoxide. I can't change that part. Carbon and oxygen have to make carbon monoxide for this equation. So now my equation, to say I got two carbons, I put the two in front, a coefficient. To say I got two carbon monoxides, I put a two in front, a coefficient. So to balance equations, the only place you're allowed to write numbers is in front of each chemical. You can only write coefficients. So that's our task. So how do we go about do this? I'm going to show you a couple of rules and then we'll do some practice and show you a couple of techniques that get it beyond the guess and hope it works. Okay? Because that's where we're at right now, guess and hope it works. Okay. Step number one, write the correct formulas for all the reactants and products. You have to describe what's really happening. If you don't write the correct formula, you're describing a different reaction. I have to make carbon monoxide, I can't make carbon dioxide, even though carbon dioxide would make my life easier balancing. The only way to make sure that you got the same number of atoms is to count them. I'm going to show you a technique that I use for counting that lets me keep track of where I'm at along the way. You balance the elements one at a time by adding coefficients in front. So the only numbers you're allowed to write are coefficients. Coefficient is the name for 2 and 2x cubed in math class. You got 2x cubed. The x is the coefficient. In 2 COs, 2 is the coefficient. And then don't forget, you're going to fix 1, check to make sure it's balanced, because if it's not, you've got to go back up to 3. That's all you do. Just put coefficients in front and check. And then try another coefficient, check. Try another coefficient, check. Which is what you did, I'm assuming, on the simulation, but it told you when it wasn't right. Okay? The mistakes that people make at the beginning, and it's hard to break them of this habit, so never change the subscript to balance an equation. Because you may have a balanced equation, but it's not the reaction we're talking about. It's on School Loop. If you want it, you can get it. And that's just going to be behind here. It's not solving the problem. H2O and H2O2 are different compounds. One of them puts out a fire, one of them makes the fire go faster. And I thought that's all I had to do, but then people surprised me by, oh, I just won't write it as a subscript. I'll write it as a big number in the middle. It's okay to put 2 in front of NaCl. It's not okay to put a 2 in the middle of NaCl. There's no such thing as an Na with a big 2 in the middle Cl. You can only write in front of every chemical. Coefficients can't go in the middle. Somebody's answer was, I just won't write it small. That doesn't work. That's it. That's all the techniques. No, we'll talk about some techniques along the way as we do some examples. Okay. So it's okay to put 2 in front of NaCl. It's not okay to put a 2 in the middle of NaCl, because that doesn't mean anything. Okay. So don't change subscripts. Don't put anything in the middle of the equation, the middle of the formula. In the equation, you can put it there. So an example, H2 plus O2. Makes H2O. That is,
That's not true.
so well, hydrogen and oxygen make water. It's true, it's just not balanced.
But you can't go like O2 is O1 now.
No, you can't. No. Okay, so but we're going to be able to balance it by putting numbers in front. But it's still going to be hydrogen and oxygen make water. Okay. Here's the technique I'm going to teach you. I like to make a table to keep track of where I'm at. And my table is really simple. There's a reactant side and a product side with every element listed down the middle. And all I did was go up here and say there are 2 hydrogens and 2 oxygens on my reactant side. There's 2 hydrogens and 1 oxygen on my product side. I'm teaching this table technique not because you need it every time, but because when it gets hard, it's nice to have a tool to use because the computer's not going to count for you. Does that make sense? So it's not a complicated table. Just list everything you got to keep track of, a reactant side, a product side. And this table tells me it's not balanced because while the H's are the same, the O's are not. The O's don't have to equal the H's, but the O's have to equal each other. So the way to think of it is I need to change that O in the product side to a 2. Okay? You're tempted to do this, but you have just changed your water into rocket fuel. We don't want to make rocket fuel. We want to make water, so I can't put the 2 there. The only place I'm allowed to write is in front. And the only direction I can make the numbers go is bigger. I can't make them smaller. So I need this to be a 2. To make that a 2, there's 1 oxygen here. If I had 2 waters, that would be 2 oxygens. Right? So I put a 2 in front of water. That changes my oxygen to 2, which is what I wanted. But it changes my hydrogen to 4. Because I got 2 H2Os. So there's 4 H's there. So you're going to find that happens really often, that you fix one, it messes up another one. But eventually they will all balance. So what do I need to fix now? Hydrogen. And I need to fix it in the reactant side because I can only make it go bigger. Right? It's got to go on the reactant side because I can only make the numbers bigger. So I need that reactant side, I need that to be a 4. First of all, where is hydrogen in the reactants? Well, it's right there. How can I make it 4? Put a 2 in front. When I do that, that makes me have 4 H's, right? And it doesn't change anything else. So now my table says I'm done. I got 2 O's and 2 O's, 2 H's, and 4 H's. So the H's have to equal each other, they don't have to equal the O's. And then the last thing is, because you're going to tie it up in the table, you're going to forget to go back up and check. Go back up and count up top. There are 4 H's on the left-hand side. There are 4 H's on the right-hand side. O2 is 2 O's, 2 H2O's is 2 O's. Every atom I started with, I end up with the same number. Okay, did I answer your question along the way, Brody?
Yeah.
Okay. Right, got a question? Okay. Okay. Now, here's another silly thing. The answer is this. That is a balanced equation. The table is just a way of getting there. I had somebody turn in a test where they gave me the table and not a balanced equation. I was confused too, but I couldn't give them credit. Okay? Now, you're not required to make the table every time. I'm not going to force you to do it. But you want to practice with it because when it gets nasty, you want something, a tool to help you keep track of where you're at. Otherwise, you get lost along the way. You can see that happening, right? So, you light a Bunsen burner. The CH4, which comes out of the jet, mixes with the oxygen in the air, makes CO2 and water. Balance that equation. CH4 plus O2 makes CO2 plus H2O. I'm going to make my table. I got a reactant side and a product side. I have to worry about carbon, hydrogen, and oxygen. On my reactant side, I have 1 carbon, 4 hydrogens, and 2 oxygens. On the product side, I have 1 carbon, 2 hydrogens, and here's the tricky part. I've got 2 oxygens here and 1 over there. I have a total of 3 oxygens. And here we're going to talk about the first of the techniques that make your life a little bit easier. If something shows up twice on the same side, don't balance it early. Because if it shows up twice, when you fix it, you're going to mess up something else, which is going to have you fix it again, which is going to mess up the oxygen again. If you've got something that shows up more than once, leave it as long as you can before you're forced to fix it. And I can fix something besides oxygen. So the reason why I'm going to let oxygen wait is because it's twice on that side. And anything I did early to fix it would, I forgot the C, didn't I? 4, 1, 2, 2, 1, 3. So I'm not going to fix the O. So if I'm not going to fix the O, I should fix the H. Sorry, my table's in a different order. It doesn't matter what order it's in. So I'm looking at H. It's not balanced. I can only make numbers bigger, so the product side has got to be a 4. So I can put a 2 in front of that. Water. That's the only place hydrogen shows up. And that will change my hydrogen to 4. And it changes my oxygen to 2 here and 2 there, a total of 4. See why I didn't fix oxygen first? As soon as I fixed hydrogen, oxygen changed again.
How do you get 3 oxygen and
2 here and 1 there. Okay. So, I still don't want to fix oxygen, but I don't have a choice. Okay, so I need 4 oxygens on the reactant side. Can I get 4 oxygens on the reactant side? Well, my oxygen's here, comes in packets of 2. So I put a 2 in front. That'll get me 4 O's, and nothing else would change. So that's it. Now I go back and check, because my table says I'm balanced, but I want to go back up and count in the equation. 1 carbon on my reactants, 1 carbon on my products. 4 hydrogen in my reactant, there's 4 in those 2 waters. 4 oxygens, 2 oxygens there, 2 more is 4. Okay? Always double check at the end because your table may be lying to you. Silver nitrate and copper make copper 2 nitrate and silver. I have a reactant side and a product side. I have to worry about silver, nitrogen, oxygen, and copper. I've got 1 silver, 1 nitrogen, 3 oxygens, and 1 copper on my reactant side. On my product side, I have 1 copper, 2 nitrogens, 6 oxygens, and 1 silver. So look at my table. What do I need to fix? Nitrogen and oxygen. Okay? Is there any reason to choose one over the other? Not really, because they both show up just once on each side. So it doesn't matter which one I fix. So I need the left-hand side to say 2 nitrogens. The only place nitrogen shows up is here. And the only way I could have 2 nitrogens is put a 2 in front of that. I can only write numbers in front. It's going to make my nitrogen 2. But it's going to mess up my silver and make that 2. And it's going to make my oxygen 6. So it messed up my silver, but it fixed my oxygen. Nope, I don't need parentheses because 2AgNO3, so I don't need any parentheses there. The only time I need parentheses is like here, when I have multiple polyatomic ions. Okay? Now what do I need to fix? Silver. And silver needs to be a 2 on that side. I can put a 2 there, it gives me 2 silvers. Doesn't affect anything else, and we're balanced. Aluminum and nitrogen make aluminum nitride. So my reactant side, there's 1 aluminum and 2 nitrogens. On my product side, there's 2 aluminums and 3 nitrogens. Okay? Any reason to pick one to fix over the other? Not really. So I'm going to put a 2 in front of aluminum and fix that. And all it changes is aluminum. So I got 2 nitrogens on one side, 3 on the other. So I need this number to be a 3. What can I write there and get a 3? No, there's nothing I can write. There's no coefficient I can write there and get a 3. Because I put a 3 there, that's 6. Okay. This is the second place we can talk about techniques. Our problem is that I've got 1 atom left to balance, and it's even on one side and odd on the other. And I can't fix it. Anytime that happens, anytime you find yourself in that situation, whatever's in front of the first thing, get rid of that and double it. So it was a 2, now I'm going to make it a 4. Just erase it and make it a 4. That's going to give me 4 aluminums. See, that's going to force you to change other things. It's going to change other things in a way to get rid of odd numbers. Because I'm multiplying through by 2. That gets rid of odd numbers. Make sense? So if I want to be 4 Als, I've got to put a 2 in front of Al2, N3. That gives me 4 ALs and 6 Ns. Now I'm at the point where only nitrogen needs to be fixed. Can I fix it? I need to be 6 on the, can I put a number there and get 6? Oh, yeah, 3 goes there. 3 times 2 is 6. That gives me 6 nitrogens. 2 aluminums, 6 nitrogens and 6 nitrogens, we're all balanced. Okay, so sodium plus water reacts to form hydrogen gas and sodium hydroxide. Worry about sodium, hydrogen, and oxygen. On my reactant side, I have 1 sodium, 2 hydrogens, and 1 oxygen. Product side, I have 1 sodium, 3 hydrogens, H2 and an OH, and 1 oxygen. What don't I want to fix first? I don't want to fix hydrogen first because it shows up twice. But I have to fix it because it's the only thing that's messed up. So what number can I put on the left-hand side that will get me 3 hydrogens? There isn't one. Why not? Because it's even on one side and odd on the other. So I have to double what's in front of that Na. What's in front of that Na is a 2. Made it a 1. It was a 1. I doubled it to a 2. Now I want to leave H till the end because other things are messed up. So I'll have to put to get 2 sodiums, I have to put a 2 in front of sodium hydroxide on my product side. And that'll give me my 2 sodiums, 2 oxygens, and 2 hydrogens there, and 2 more is a total of 4 hydrogens. No, I leave the molecules together. I can talk about how many molecules there are.
But H2O is a molecule.
Okay, there's no, but
There's no H2O.
okay, so what we're talking about is atoms have to. Okay, and that's what has to happen in a chemical reaction. The atoms have to rearrange, so the molecules have to come apart and make new molecules. They have to. We said they can't be created or destroyed. They're only rearranged. That's why they're all still there. Okay. Hey, can I fix hydrogen now? Oh, I got to fix oxygen first, don't I? So notice I can stop and talk to somebody and then come back, and my table's got the right numbers there. So I'm not lost. Okay, I need to make that O a 2. So I put a 2 in front of water because that's the only place O shows up on the reactant side. It gives me 2 oxygens and it gives me 4 hydrogen. Isn't that convenient? I don't have to work at fixing hydrogen. It did it for me. Sometimes that happens. When you have 2 things mixed up, fixing one will fix the other one along with it. It's okay? So this is taking the place of the computer counting for you. And that's all it's doing. So just because if I don't put it in the notes, if it doesn't show up on the screen, nobody wrote it down. I mean, how many people wrote this down, even though I said it twice? Kept mentioning, hey, I don't want to fix hydrogen first. But it's not important until it shows up on the screen, even though it was the secret to doing some of those pieces we just did. Let's think about note taking. And here's how you write up about that double. Fix everything except one element. Got one left to go. And it's even on one side and odd on the other. Double the first number. Whatever in front of that first element, whatever there, double it. And move on from there, and it'll get rid of your odd numbers for you. Most often it's going to be putting a 2 in front, but the real technique is to double it. Because if there's already a 2, we want to double it to a 4. Like we did with aluminum nitride. Okay, so here's an example of an equation where both of those show up. Here's what the reaction looks like. Butane combines with oxygen to make CO2 and water. There. That's the reaction.
Do you just walk around with a cigarette lighter everywhere?
I'm a chemistry teacher. I light things on fire all the time. It's part of my job description. Now, you should see the looks I get when I order 50. I need 50 cigarette lighters. I'm a science teacher. We buy bizarre stuff. Okay, so reactants, products, carbon, hydrogen, and oxygen. 4 carbons, 10 hydrogens, 2 oxygens, 1 carbon, 2 hydrogens, and O shows up twice, 3 oxygens, CO2 and H2O. Okay, so what don't I want to fix first? Because oxygen shows up twice on the product side. Doesn't matter which side it shows up twice. Shows up twice, I don't want to fix it early. So I'm just going to mess it up as soon as I write another number. So I don't want to fix oxygen. What should I fix? Carbon. So to fix carbon, I need my product side to say 4 carbons. So I put a 4 in front of CO2 because that's the only place carbon shows up. And that gives me 8 oxygens there, and 1 more is 9. Still don't want to fix oxygen. So I need to fix hydrogen. So I have 10 in my reactant side. I need 10 in my product side. That means I have to put a 5 in front of H2O to give me my 10 hydrogens. So that will give me 10 hydrogens, but it's going to change my O again because there's 5 here, and then 8 from there is 13. 5 from the H2O, 8 from the CO2, 13 altogether. So now I have to fix O. It's the only thing left. So what number can I put on the reactant side and get 13 O's? There's nothing, right? Because one side's even, the other side's odd. So when you reach that situation, it says whatever in front of this first one, double it. So right now there's a 1, so I'm going to make it a 2. It's going to mess up everything, but it's going to mess it up in a way we can fix it. Because that gives me 8 carbons and 20 hydrogens. So that means I'm going to have to change my numbers. And notice what I do. I just get rid of the old number and put the new number in. I don't care what the number was before. I need it to be an 8 now. So that gives me 8 carbons. There's 16 oxygens there, and 5 more is 21. Got to make my hydrogen 20 on the product side. So I don't want a 5 in front of water. To be 20, it would have to be a 10. That would give me 20 hydrogens. And it changed my oxygen to 16 here, and 10 more is 26. Now I have to fix oxygen. I need 26 on my reactant side. Can I do that? Yeah, if I put a 13 there, that'll give me 26 oxygens. And then I do that last thing, which is check. 8 carbons, 8 carbons. 20 hydrogens, 20 hydrogens. 26 oxygens, well, there's 16 here, and 10 more is 26. Okay? And that's how you balance equations. So you practice some with the computer. Now it's time to practice some without. Okay, give you one clue on this assignment, or on all the balancing. If you have to write a coefficient bigger than 25, justify it. Make sure that you have to. Okay, it's possible. I know of balanced equations where the smallest coefficient is 165, and the biggest one's over 700. Okay, I'm not giving that one to you. Okay, so you should never write a coefficient. You should always double check to make sure if you get a coefficient bigger than 25 that you really haven't made a mistake someplace. I'm not saying it's impossible. I'm just saying we tend not to run into them